Good morning, grade fours, and welcome to another science lesson. I had a very good night's sleep, so I am in a particularly good mood, and I'm excited to learn about science today and continuing with our topic about sound and sound energy, which is very cool, especially what I've got lined up for you today. Remember that, boys and girls, if you've got any questions from anything from today's lesson, please email them to grade 4 over there at WorksheetCloud.com. Right, so the joke for today, and I hope that you are sitting back and relaxed and ready to have a bit of a chuckle, because I sure did. Okay, what do you get when you cross a vampire with a snowman? What do you get? And the answer, drumroll please, frostbite. Frostbite. I loved it. I just thought it was appropriate because it is getting chilly with our change of weather. So, right, are you ready to begin? So we are going to begin today's lesson with something a little bit different. I'm actually going to, in our starter activity today, I'm going to give you a really cool fact. When I came across this, and I didn't know this, I just felt like I had to share it with you because it is really cool. And I bet some of you didn't know this because I definitely didn't know this. Okay. So this is more of like a little fact. This has got nothing to do with energy or sound energy, but it's something completely random, but I thought you might enjoy it. Okay, so the question is, do icebergs have to be white? Do they have to be white? What would be your answer? So yes or no, and give me a reason why. So pause the video, say yes or no, and think. Remember, science is all about thinking. Do icebergs have to be white? Yes or no? Okay, pause. What do you think? Want to see? Okay, so first of all, the answer is no. So interestingly enough, look at these icebergs. White ice contains lots and lots of air bubbles. Light reflects off the bubbles, and so that's why the ice looks white. But sometimes you get these blue stripes. So look at this iceberg here with this blue stripe. And blue stripes may be formed when water fills in the cracks in the iceberg. And because it's so cold, it refreezes very quickly without any air bubbles in it. So the ice only appears white when there are lots of air bubbles and the light is actually reflected off those air bubbles. And so that's why it looks white. And funny enough, look at this iceberg over here. Green stripes come from cracks which have been filled with seawater containing algae, and then it is frozen. Look how amazing nature is. Don't you think it looks like a piece of marble, like beautiful marble? I did not know that. I must say, I never knew that you can get these green cracks in icebergs, and they're formed from seawater that contained algae, and that it froze very quickly without bubbles. Here is another picture over here to show you different colors of icebergs. Have you seen this? I must say, with all the, okay, I've never been to cold places like this, but watching documentaries and National Geographic and shows from places like this, I've never seen icebergs this particular color, and pictures, I've never seen icebergs like this. So when I came across this, I thought it was very cool. And this is just a very cool fact that I want you to go and share with your brothers and sisters and your families and your aunts and uncles and maybe your next door neighbor, obviously from a distance. And so share. Remember, we live in such an amazing world, and there are amazing things all around us, and you know what, there's always something new to learn every single day. So I told you, science is awesome. So Okay, so now we learned a little bit about icebergs. Let's move on to energy and sound. Okay, so today we are specifically going to talk about the vibrations and sound. Okay, so yesterday we learned that sound, we hear sound, and sound is caused by vibrations. And remember, the vibrations happen where? What vibrates? How do things vibrate? And so remember, we spoke about in the air, you're able to hear me, and I'm going to touch on a little bit more about that a little bit later. But you're able to hear me because as I'm talking, the sound energy and the sound waves are passing in the air, and the particles in the air are vibrating one next to each other, and so that energy travels in the air. Okay, and so this little picture here, I thought if you're at home or someplace where you've got a table and you've got a ruler maybe lying around, I want you to try it. Get your ruler on your table, hold one part of the ruler, and with the other part over here that's hanging off the table, just move it up and down, and you'll see that it actually produces a sound. And why is it producing a sound? Because this ruler is actually vibrating. It's pretty amazing. This picture over here is of a tuning fork. So when you bang a tuning fork, there's a little sound, and it's the sound that is emitted from the tuning fork is based on the vibrations. This particular fork moves and it vibrates and then emits a sound. It is very, very cool. So just to summarize, we know that vibrations cause sound, but can sound also cause vibrations? Don't you see how I like to mix it up a little bit? So we know that vibrations cause sound, but reverse, does sound cause vibrations? That's what we're going to look at today. So to answer that question, we're going to do a little bit of an investigation. Okay, and to do this investigation, you're going to need a better view of me. So here I am. I'm wearing my glasses today because my eyes are straining quite a bit. So me in all my glory. Right, so in order to demonstrate that sound also causes vibrations and vice versa, I have got, let me actually take this off for a second. What I've got here is I have got a bowl, just a normal glass bowl. And do you see I've put cling wrap or cling film over the bowl? It's quite tight, right? And so if I hold the bowl, if you listen very carefully, and I'm just tapping on the cling wrap, you should be able to hear what is happening. Now, at the moment, you can't see sound. Okay, so all we can do is we can hear as I'm tapping. You're hearing the sound of me tapping. But now, remember my question was, can sound cause vibrations? So in order to demonstrate that, I have got good old-fashioned rice that I'm going to put on the center of my bowl on top of the cling wrap, right, as you can see. So I'm sure you've got, there we go, I'll come closer so you've got a really great video. Okay, so now as I tap the cling wrap again, look what happens to the rice. What happened? Okay, do you all see that the rice is jumping around like crazy? Now what does that mean? How is the rice able to jump around and we're still able to hear it? Now, remember that when I was tapping it before, we could hear the sound of the cling wrap. But now, do you see that as the rice is moving up and down and jumping, we're able to see the evidence that sound also causes vibrations. The sound of me tapping the cling wrap is causing the little rice grains to vibrate. Okay, the second thing that I'm going to try with the rice, I just need to get it all in the center. Okay, so there we go, it's back in the center. So I tried this when I was preparing for your lesson, so I hope it's going to work now. I'm going to hum, and you better not judge my humming, but I'm going to hum, and as I hum, let's see if the rice moves just by the humming of my voice, because I can't sing. That's something I've come to terms with, and I've made peace with the fact that I can't sing. Okay, so let's see. How cool? Did you see the rice? If you were able to see, it did vibrate, and it did move. And boys and girls, that is a fantastic example to show you how we can see sound. We can see the vibrations that sound that creates and sound makes just by using rice as a demonstration. So let's get back to our presentation. Okay, and play. Okay, so this is exactly what we did, and you saw that the little rice grains were jumping around like mad. So what can we conclude based on what we've just seen? Okay, so what can we learn from what I've just shown you? So firstly, tapping the cling wrap gives it energy to vibrate. Okay, so remember, as I was tapping the cling wrap, it gives it lots of energy and it starts to vibrate. The sound grains are only there for us to see the vibration. So remember, it's only there as a visual representation for us to just see what is happening in this particular little experiment. Making a sound near the cling wrap causes the rice grains to jump around. Okay, and this means that the cling wrap is vibrating from the sound. So to sum up, sound does cause vibrations that you can see. And what did we use to see it? We used little rice grains to show us that we can actually see sound. Okay, so now it brings me to talk about how do we make sound. Okay, so as you can see in this particular picture, we have a throat. And what I want all of you to do is, where you are right now, I want you to just put your hand on your throat and I want you to hum. What do you feel? Even while you are talking, possibly, while I'm talking, I can feel my throat vibrating. What is going on there? Well, let's see. So when you placed your hand over your throat and you hum, all of you should feel a vibration happening in your throat. This vibration causes the sound that comes out of our mouths when we speak, hum, sing, shout. And so that those vibrations in our throat, those vibrations cause that sound, and that sound then comes out, and however we sing or shout or hum or whisper or anything, that is the sound that comes out, and it's caused by the vibrations in our throat. Now, what is in our throat that causes those vibrations? It is our vocal cords. And what's interesting is that as air moves over the vocal cords, so here's a little vocal cords over here in our throat. Okay, and the scientific term for our throat is called your larynx, just an interesting fact. So as air goes over our vocal cords, remember, as the air goes over and we want to sit and speak, it starts to vibrate, and remember that vibration then causes sound. Cool, huh? Very, very cool. So how do now we hear sound? So we've spoken about how we see sound, how sound happens, and now how do we even hear sound? How do we begin by hearing sound? So when sounds are made from the vibrations of our vocal cords, this sound energy travels to our eardrums. Now remember, we've got an outer part of our ear, and then we've got an inner part of our ear, as you can see in the picture. Your eardrum is almost like a thin membrane that you can see sits deep within your ear canal right here by your ear. So as soon as sound energy hits our eardrum, the eardrum starts to vibrate and then the sound goes into our ears. Now also, interestingly enough, that right next to the eardrum, there are these little bones, these tiny little bones in our ear. And these little bones are connected together. And when that eardrum starts to vibrate, the vibration hits the bone and the one bone bumps against each other, and those bones then bump against each other, and that energy is transferred from one bone to the next until it hits our nerves and then travels to our brain, and our brain interprets that as sound. Bet you didn't know that. Told you science was cool. Okay, so an interesting fact. One of the smallest bones in our bodies is called the stapes bone, and it is found inside your ear. So remember the bones that I told you right next to our eardrum, that the bones are sort of joined together and then they start to vibrate and bounce. So that is this little bone over here called the stapes bone. So have a look at what it looks like, how small it is on this person's finger. So that is the one bone, the stapes, and then those are the other two bones inside of our ear. It is tiny. So an interesting fact, the smallest bone inside our body is called the stapes or stapes bone. However you want to pronounce it, stapes, stapes. I always call it stapes, but I don't actually know if it's right. Stapes, okay. And it's found inside your ear. Very cool. Right, so now we know that sound vibrations travel through different materials. Okay, and that's something that now I want to just go into a little bit more detail. We've spoken about sound traveling through air. Okay, but sound also travels through solids and liquids. So sound actually travels through all three types of mediums. So the substance or the material in which sound travels, we give it a special name, and it's called the medium. So when we speak in science, we talk about what medium does the sound travel through. Does it travel through a solid, a liquid, or a gas? Okay, so it's very important to know that we refer to it as a medium when we talk about a solid, a liquid, or a gas, and how sound travels. And this is, and we do different experiments to see, does the sound travel faster in a liquid or a solid or a gas? And there's so many different experiments and investigations that you can do that involve sound. So the first thing that I want to just talk about with this particular picture, and maybe this is something that you guys can try at home, because you know me, I'm always giving you activity ideas for you to do at home during lockdown. So I want you to you can get 2 cups or 2 tins or 2 sort of anything, a cup, okay, not this type of cup because you won't be able to make a hole, but I would say a tin or a little cardboard cup or something like that. You're going to make a little hole at the end of it. You're then going to tie a piece of string from one cup to the next. Get a partner or get a friend or a family member, and when one person talks through the cup, I want the other person to hold their ear to the cup. Try and make your string a little bit long, so maybe from one room to the next. Talk through the cup, and the other person I want you to hear, and see what happens. Now I'm going to tell you what happens. So it actually works. You are able to hear somebody, and it's basically the only thing that you connect to is this cup and a piece of string. Now how on earth does that happen? Well, here's another example. If there is a wall between, say, you and your brother or your sister or your mom or your dad, or if you're standing, one person is standing on one side of the wall and the other person is standing on the other side, how is it possible that if you knock on the wall or you tap on the wall, the other person will be able to hear it? How is that possible? Well, it is possible because sound can travel through solids, right? Sound can travel not only through gas and through air, that's how you are listening to me speak. Sound can travel through solids as well as liquids. If you are under the water and you shout, you're under the water and you hear somebody shouting under the water, sound can also travel through liquids as well. And that is how dolphins and whales, that's how they communicate to one another. Do you remember about 2 weeks ago when I spoke about echolocation with dolphins and how they communicate with the sound waves underneath in the water? And that's exactly what happens. Sound travels in water as well. Right. And remember, how does sound travel? Sound travels when one particle, whether it's a solid, a liquid, or a gas, that energy travels through the other particle. They vibrate and it travels. Vibrate, travels. Okay. And those vibrations, almost like a piece of string, those vibrations, the vibrations pass on from one particle to the next, and we are able to hear sound. Okay, so vibrations cause sound, and sound causes vibrations. So to summarize, sound must travel through something. Okay, so we've spoken about either air or a gas, a solid, or it can be a liquid. Your voice can travel through string. So I want you to really try it. If you're able to try it, a string, 2 tins, or cardboard, something that is easy to poke a hole at the bottom of your tin that you can put a piece of string through. Tapping sounds can also travel through a wall. So maybe as an activity with you and your friend or your brother and sister or somebody who is at home, maybe come up with your own sort of Morse code on the wall. 1 tap equals an A, 2 taps equals a B, a tap and a pause and another tap equals, because that could be quite cool. And then we said here, the medium your voice travels through is air. Remember, that is so important. The word medium is the substance in which sound travels through. So what medium is sound traveling through as you are listening to me? It is air. Good. And remember, we've established that sound can travel very well through solids. I want you to try your tapping. I want you to try and make your telephones that are connected with a piece of string and just have fun with it. So I don't know about you, but I really enjoyed that lesson. And if you've got your own cling film at home and you've got some rice and a bowl of some kind, I want you to show your mom and dad. Go and show them what you've just learned and tell them the cool fact about ice. So remember, there is a cool activity as well to do along with this lesson, and I encourage you to do so. Boys and girls, this was fun. I've had a blast. I hope you have a wonderful day, and I'll see you soon. Hakuna Matata, and be kind to one another. Bye.